welcome to another video for Algebra 2. In this video I'm going to be working out your worksheet, a few problems from your worksheet 3.4 or 3-4, solving quadratic equations by factoring. So this came by request over Thanksgiving break, so I'm going to be working out problems 10 through 15 and you are factoring, okay? So recall from lecture that factoring is essentially the reverse of foiling. So instead of putting together, you're kind of separating apart. Try to imagine, having a pizza, and factoring would be like taking out the individual ingredients. Let's say you had like a veggie pizza or something with a bunch of vegetables, and I were to say factor out that pizza. Factoring would be you taking out all the tomatoes and putting them in a separate pile, all the onions in a separate pile, and all the olives and whatever else, all the different ingredients in separate piles. So that's kind of what we're doing here with problems 10 through 15. And as I'm looking at number 10, one of the first things that I want to do, keep in mind as I'm looking at these problems, is I want to look at each one of these terms right here. I want to look at each one of these terms, and I want to ask myself the question is that what do these terms do? Is there anything that they have in common that I can then factor out? Is there a term that I can factor out that they all have in common? And as I look at this problem carefully, I notice that they all have a particular term in common, and that's the r. Okay, so with my first term, my leading term here, I have three r's. Remember, r cubed is the same thing as r times r times r. And then in my second term, I have 3r squared, which is r times r. And then in my third term, I have 54 times r, so just one r. So the first term has 3 r's, the second has 2, and the first has 1. So that means the maximum amount of r's that I can factor out from all of this is 1 r. Okay, so 1 r from each. So I'll take out this r from this term, this r from that one, and then that r from that one. And what I end up with is, so I factored out an r, so I end up with something that looks like this, r times, okay, and then with this term, I factored out 1 r, so I have 2 r, so I have r squared, plus, and then in this one, I've factored out that one, so I'm left with 1, and don't forget about the coefficient 3r minus, and then over here, I factored out that 1r, so I'm left with only the constant of 54. Okay, and that's where I'm at so far. Okay, cleaning up my problem here. So this is what I'm left with so far. So I have an r times this polynomial right here. And so the next question I want to ask myself is, now I need to factor out this particular problem. So remember that when I factor out, I'm going to end up with something that looks like this, right? I'm going to end up with two binomials. Okay, and I know because I have an r squared here, I'm going to have two r's to begin with, right? And then I have a plus and a minus, so that means one of these will be plus and one of these will be minus. So the next question I want to ask myself as I'm looking at this problem is, and this is the trickier part of this, is that what are the two terms that when I multiply them out will give me 54, but when I add them together will give me 3? So the key is looking at this. Remember, I need two terms. So what are the factors? What are the factors of 54? Okay, that's the thing that you got to ask yourself. So I know 9 times 6, right? Actually, if I look at that right off the bat, 9 times 6, what's the difference between these two? But 3, right? So that means that therein lies my my solution. So the next question I got to ask myself, okay, so this could possibly be my two factors that I put in here, right? So the next question is, which goes where? And the key lies in looking at my 3. I have a positive 3. Since I have a positive 3, that means I know that when I compare 9 and 6, I know that 9 should probably be the positive term. Reason being is because when I add 9 to negative 6, I'm going to end up with a positive 3. But when I multiply positive 9 with negative 6, I end up with a negative 54. So that's kind of the logic that I follow when I'm solving this. So this is my final answer. It's r times r plus 9 times r minus 6. Cleaning it up, and there you go. Actually, let me write it over here so it's a little neater. R plus 9 and r minus 6. Okay, so next, moving on to the next problem. So I'm using the same mindset. Again, I'm looking at my three terms, and I'm asking myself, is there anything that they have in common? Now, in the previous one, I had the variable that they had in common. Here, I don't have a variable that they all have in common, because here I have two a's. I have one a here, but then I have no a's there, so it's only a constant. So since there are no variables that they have in common, is there anything else that they have in common? What about the coefficient? Here's a coefficient, here's a coefficient, and then this is just a constant. But is there a factor that they all have in common? 8, 2, and 6. Is there a factor? Okay, and it is 2. So I can extract, actually let me do it the other way. I can extract from all of these terms, I can extract a 2. And again, I'm going to most likely end up with a binomial, and I know that they all have a 2 in common. So what would be left over? So I have 2. Actually, so I know I have a binomial. That's going to be the way it ends up. But just right now, as it stands, I extracted a 2, so I'll end up with 2 times, and then I got to ask myself, what do I need to multiply this to get? What do I need to multiply 2 by to get an 8a squared? And that's 4a squared, right? Because 2 times 4a is 8a squared, plus an a, because 2 times a is 2a, and then minus, what term do I need to multiply 2 by to get negative 6? And that's a minus 3. So this is what I end up with right now. This is my next starting point. So as you can see, I transferred my 2 over, and now I know that this middle term here, I'm highlighted in yellow, this middle term needs to turn into a binomial. And if I look at it carefully, this can be kind of tricky too, because they have a 4a here, right? So that means, see, I have an a and an a. Let me use a smaller. An a and an a, and I know that's going to give me an a squared. But I can have a 2 and a 2, because that'll give me 4, or it can be just a 4 and a 1. And I'm just going to go ahead and guess a 4 and a 1 for now. Okay? That might be wrong, but we'll see. Okay? So what did we have here? We had an A, and then a 4 and a 1. So 4 times a is 4a squared, like we have here. All right? So the next question again that I want to look at is, what two terms can I multiply to get a 3, but when I add them together will give me an a? Okay, so what two terms can I multiply here? So 3 and 1 is, 3 is a prime number, so it's got to be 3 and 1, right? So it's got to be 3 and 1. 3 and 1. Now right away I see a problem. And I hope you caught this, but if not, look at this. I have 2 pluses, but here, let me clean this up a little bit. Here I have a negative and a plus. That means one of these over here have to be a plus or a minus, right? And that's the tricky part. That is the tricky part, because it's made all the more trickier because I have a 4 right here. Okay? So, having said that, I'm going to guess, oops, what would I have here? A plus 3, right? 4 times 1 is going to be a positive 4a, right? See, I know this times this is a 4a squared, right? And then I know 4a times 1 is going to be a 4a. Okay? So, if that's going to be a 4a, that must mean, here, I'm going to change this from a plus 3 to a minus 3. The reason why I'm changing that is because I'm noticing that if I multiply negative 3 times 1a, that's going to be negative 3a. And when I add these two together, I'm going to end up with a positive a, which corresponds with my positive a right here. And in fact, I noticed that when I multiply negative 3 times 1, I end up with a negative 3. So when I multiply my outermost, I end up with this outermost. But when I add them together, I end up with a positive a. Okay. Now again, that's not super obvious, and you know, I just happened to get it on my first try. And you know, it might take some guessing and a little bit of luck to get it the first time. Otherwise, the more problems that you do, the more intuitive this becomes, and the less guessing you'll actually end up having to do. Okay. And hopefully you were kind of able to follow my thought process there. So so here we go. That's the answer to that problem right there. Is this? That's that factored out. That is that quadratic equation being factored out. So let me write the answer over here. 2 times 4a minus 3, and then a plus 1. So let's work out some more. All right, next. Ooh, another tricky one. Another really tricky one. So I noticed that there's only two that have the variable, so I can't use the variable as to factor out. And this coefficient is 1, and this one's 14, and this one's 49. So these two have 7 in common, but this one does not. So I can't really use that. Interesting. Well, what I do notice, so I have a c squared and then I have a 49, and 49 technically can make a perfect square. For example, if I factor out the c, and I put the squared minus 14c plus a 7 squared. Okay, on the surface that may not seem like a big deal, but it actually kind of is, because it just so happens that this 7 right here, which I extracted from the 49, this 7 is a factor of 14, which will come into play as to how I factor it out. Because this 7, when I multiply this number out, I end up with the 49, but when I add them together, I end up with the 14. And if you recall, that's the thing that I've been following throughout. That's the pattern that I've been following throughout these problems, is that the factors have to multiply out to your last term, but they have to add up to your middle term, right? So, and again, this is not always necessarily obvious, but that's just some of the, you have to kind of play detective and follow the clues and see what clues are available to you. And I just happened to spot that 49 being a perfect square. So I use these terms right here as my base, as for my binomial, and I'm going to use c minus 7. Okay, and they're both squared, so I can just square that out. And that actually makes sense, because if I do this, c minus 7 times c minus 7, that's going to give me c squared, and then minus 7c, and then the next term, negative 7 times c, is negative 7c, and then negative 7 times negative 7 is plus 49. And then I have two like terms, so I end up with c squared minus 14c plus 49, which is exactly what I started out with over here. Okay, so again, that's just the type of thing. That's just the type of thought process you kind of have to have when working these out. Now, if you look at number 13, actually 13, 14, and 15 all kind of look the same in that regard, because if you look at 14, for example, I have a squared here, and 4 is a perfect square also. So I end up with x squared plus 2 squared. So then these two terms will be the basis of my binomial. Okay, so I end up with x, and then 2, 2. See, now here's a tricky part. This is very tricky. Oh man. And this actually goes over something that we will discuss in class after break, which is your complex numbers. You'll notice something really important here. We're missing a middle term, right? Because you notice with all the other ones, we have a middle term, right? And even here we have a middle term. But what happens when you don't have a middle term? And the tricky thing is that this is a positive number, so that means, yeah, see, to be missing a middle term, you have to have a plus minus sign. But that doesn't work out for here because I have a plus sign. So that must mean that we might be dealing with complex numbers here. Whoops. Yeah, because I times I is -1, and -1 times -4 is +4. Yeah. So there's a rule here. So let's see here. X times x is x squared, and then the plus -2i. I'm sorry, the x times -2i with the positive 2i times x. So we're going to put -2i plus +2i, and then -4 times I squared, and I squared equals -1. So these here cancel out, right? And you end up with -4 times -1, which equals x squared plus 4. That was a really good one. That's a tricky one. And a lot of what I just did may not make sense because we have not gone over complex numbers, because that's in section 3. And like I mentioned before, right before we left on break, I would discuss that once we got back. So, so yeah, that's kind of where we're at with that one. So, rewatch that part. If you don't get that, don't worry. We will address that when we get back. Okay? Oops. Okay, let me make some space here. All right. So same thing here. Look at that. We have perfect squares, right? So for this one, it would be 4 squared times r squared minus 169. The perfect square there is 13 squared. So then that means these base numbers are going to form the terms for my binomial, right? So it's going to be 13, 13, and then 4r, 4r. And again, we don't have a middle term, so you know one of them will be plus and one of them will be minus, and that essentially does it for that one. Okay, so I hope you're noticing the pattern here. Okay, let me erase a lot of this mess here. Let me erase a lot of this. Oops, I probably should have kept that. That's okay. That's one of the patterns that I hope you're noticing, is that any time. Okay, so you'll notice that there is a middle term, there's a middle term, and a middle term, and the bottom ones don't have middle terms. So anytime you're missing a middle term, you know that you're going to have a plus minus binomial, right? With the now you're going to have a plus minus binomial, but you're also going to have a minus a coefficient. Now again here, this is the tricky part about number 13, is you had a plus coefficient, which is why it ended up being, what was it, 2i, x minus 2i, because that I squared, again, I squared is equal to -1, and that -1, so 2 times -2 was -4 times -1, which made it a +4, which is what you had here. So, and that was the tricky part about 13. The tricky part about 13 is that they were using complex numbers, and you have to have complex numbers because you had a missing term, a missing middle term, but you only had a binomial here, and on top of that, the operation was plus. Okay, so and then you compare that to number 14. You had a missing middle term, but the middle operation was minus. So that means it just followed the normal convention, mathematical convention. It didn't go outside of the normal numbers that we use. Let's see. Whereas 13 went into complex numbers. Okay, so again, 15, same thing. We are missing the middle term, and the operation is negative. So then that you know automatically already that you're going to have a plus minus somewhere. And so now the key is to find out what goes into my what terms need to go there. And again, let's zoom in. One of the things that tip me off as to what I'm going to use is I look at b4, and that is b squared, right? That ends up being b to the 4 minus 9 squared. Yes? Because 9 times 9 is 81. So then I know that these bases will be my terms. Yes? So then b squared, because b squared times b squared is b4, right? And then the other term will be 9, right? So b squared times b squared is 4b, b to the 4th, and then b squared plus 9b will be canceled out by negative 9 times b squared, right? So that's 9b squared, and then minus 9b squared, which equals nothing. And then finally I end up with negative 9 times positive 9. Negative 9 times positive 9 equals negative 81, which is exactly what I have here. Okay? All right, so that does it for that. Feel free to email me again if there's any issues with this, and good luck in your studying.